Okay, 201 nice question. This question here says that we have 21 boys, 11 girls, and then we now need to select 5 students. And it should consisting of at least one boy. How many different committees can be formed? So now asking how many, not the possibility. Not the possibility means that you don't need to use the event outcome to over the total. You don't need to do this because now it's not about the probability. Now just asking you how many. Actually now it's asking event number. Okay, event number. How many ways? How many different ways to form the committee? So here we have at least one boy. It means that we can have 0, 1, 2, 3, 4, 5. So this 5 cases here can be counted as the at least one boy, right? Can be counted in the combination. If we add up 5, it takes many time. How about we use 1 minus? Use 1 minus this one. Okay, 1 minus happens in the situation that we are talking about probability, right? So when we talking about probability, we use 1 because we know all the probability add up equals to 1. But now it's finding how many number, how many way. Then you don't need to over. You don't need to divide the total number. So what happens here is the total weight of happen, which is altogether 32 people, randomly choose 5. This is the total weight of doing it. Minus the case of this one. This one, we don't want it to happen. We only accept this 5 cases here. So we minus it. In this case, is 21 boy choose no boy. And then 11 girls choose 5 girls. And then after you minus it, you will have the number of way of getting 200,914 different committees. Okay? So if you don't want to use the minus method, you need to add up this 4. How can you add up this 4? Is that 21 boy choose 1, C11 choose 4, plus 21 boy choose 2, and 11 girl choose 3, and then plus, okay, plus that's 5 cases, okay? So you don't need to over the total because now asking you how many ways. 2015 paper. So now in bag A, we have 4 number, and in bag B, we have 5 number. If one card is randomly drawn from each bag, find the possibility that sum of the 2 number drawn is less than 9. So first, this is in part A1, so it should be an easy question. And then we follow the rules of probability, the favorable outcome over the total number. So how many total number we have is 4 times 5, right? 4 times 5. Or you can say 4 pick up 1 times 5 pick up 1. Or just 4 times 5. Because this one actually equals to 4. This one actually equals to 5, okay? Okay, so under the line, we have the total number 4 times 5. And then upper the line, the favorable outcome is the sum adding up smaller than 9. So in this easy question, you can just count the number because actually in total you have 20 outcome. So you just count it. What possibility we have? 1 plus 2, 1 plus the 2, 1 plus 4, 1 plus 6, or smaller than 9. Smaller than 9, you cannot equals to 9, okay? Cannot equals to 9. And then 3 plus 2 plus 4, smaller than 9. 7 plus 2, already larger than 9. 5 plus 2. So how many favorable outcome we have? Here is 3 plus 2 plus 1, which is 6. So 3 over 10. 2018 question 4. So in the box, we have n white ball, 5 black box, 8 red box. Now we randomly join a ball from the box. The possibility of getting red is 2 over 5. Okay, so finding the probability, we will use the favorable outcome over total outcome, right? So total how many balls we have is adding up this one, and then equals to the probability, okay? Equals to the probability. So cost method, you will have n equals to 7. Okay, so 2016 question, you can see this question asks you to form a queue. So this is lining up question. For lining up question, you need to use P. You need to use P. Why? Because the orders matter. When the boy standing at the front, standing at the second place, it means it's different combination already, okay? Okay, so when we think about this question, we have 4 boys and 5 girls. Find the probability that no boys are next to each other. No boys are next to each other. It means that between 2 boys, we must have a girl. Or 2 girls. So, we first draw out the girls. The girls standing at their position, they can interchange, right? So, this is girl 1, that's girl 2, that's 3, girl 4, girl 5. That's 5 girls here can interchange. 5 can standing here, 2 can standing here, 3, 4, 1. This is another combination already. So, what happens here is 5 girls, we're picking 5 of them, but they have different order. So, 5p5, 5p5. In your calculator, 5p5 is not equals to 1 or 0, okay? 5p5 means that 5 girls, they have different order of lining up, okay? Okay, now for boy. For boy, they can only stand at the position labeled in blue color. What I mean here is because between them, they must have a girl, right? So, the boy can be here, 1, 2, 3, 4, or 1, 2, 3, 4, or this one. Okay, you don't know. 2 girls can next to each other, but no boys can each to each other, okay? So, 5 girls, we have 6 position to let those boys stand in, okay? Those boys can stand at this 6th position. So, we are saying that 6th position, those boys choose 4, and with P, it means that the order matter, okay? If it's C6C4, it means that 6th position, you choose 4 to stand. But it doesn't count the combination, okay? It doesn't count the order. But for 6p4, it means 6th position, you choose 4 to stand, and it count the order. It count the order for you already. You just type into the calculator, you can see. And then, over the total, right? The total outcome. So what is the total outcome? We have 9 people here. Originally, they can just randomly stand, right? They can have all position they want. So it's 9 people standing at 9 position. And then the order matters. So finally, we will have this possibility here. Okay, try to understand what is P. The logic of P and C actually is very similar, but just the orders matter now. In C, if it's 5 people choose 5, it equals to 1. Okay? But for P, because choosing 5 people, they standing in different order, it also count in the combination. So P5, 5P5 in calculator will show you the number of different way to form it. Okay? Okay, here. Another similar question, you can try it yourself. So we have 7 teachers and 3 students. So this year, I think we have high possibility to have this type of question. Why? Because we already have 3 years having the combination C question. Okay, the C question. So this year, it may be P. Okay? So now we have a cube formed by 7 teachers and 3 students. Now, how many different cubes can be formed? Okay, very easy. So we have 10 people. They have different order, so 10p10, 10p10, okay? Find the possibility that no students are next to each other, okay? It means that in the middle, we should have a teacher. You can draw a graph like this. 7 teachers, then how many positions can the student to get in? It's 8 positions the student can get in, okay? 1, 2, 3, 4, 5, 6, 7, 8. And within those 8 positions, only 3 students will get in, right? So, 8 positions, we now choosing 3, and order matter, so we use P here. And this 7 teacher here, they can change their position, right? They can change their position randomly. So it's 7 teacher. We choose 7 teacher out of 7 teacher, but they can change order. Okay? Okay, the total outcome. Over the total outcome is P 10p10. 10 people, and originally they can randomly change their position. 10p10. This is the probability here. Okay, for 2018 question, in part B, we have also the P question, and then giving you 8 number. How many different 8-digit phone number can be formed? So we have 8 number, and then how many different ways are there in the combination? So now 8 number form an 8-digit phone number. So 8 number you need to choose 8, right? But the order method. So P8A APA equals to this number here. Okay, it's that easy. So if the first digit and the last digit of 8-digit phone number are odd number, how many 8-digit phone number can be formed? Okay, this one you need to think. You need to think of it. So for the first digit, how many number we can use is you can use the odd number 3, 5, 7, 9. So 4 of them. So you can only choose 4. You can just only choose 4 out of 8. But now it's not finding the probability. Be careful of that. This is not finding the probability, so you don't need to over the total outcome. So just 4, and then if here you choose one odd number, then the last digit you only have 3 left, right? If you already choose one in the first digit, let's say you already choose 3, and then for the last digit, you can only choose from this 3 odd number here. So 4 times the last digit should be 3 times in the middle. In the middle, we have 6 number, right? We have 6 number. Those 6 number just randomly change their position. So 6 number, I choose 6, and then they change their order. Okay, so finally we have this one. This one, first digit, the middle 6, they just randomly change their position, change their order. And then the last digit, I only have 3 odd number left. So it's this one, okay? Or you can use this one. This one means that 6 number in the middle, they can interchange. And for the first digit and the last digit, we have 4 odd number, we choose 2. And this 2, they can change their order, okay? So if you understand this, you can use this. If you understand this, you can use this, okay?